Okay. So good afternoon, everyone. My name is Adejumo Ridwan Suleiman. So welcome to our study group, R for Epidemiologists. So in this book, in this study group, we're going to be using the book, The Epidemiologist R Handbook, so which all of you have already received the link. I'm very sure about that. So this study group is actually an interactive session for all of us. So what it entails is just that since most of us already have the book, so before each meeting, we try and make sure that we go through the chapter we're going to be discussing for that particular meeting. So it's expected of us to have already glanced through, let's just say the first chapter, and in this case is art basic, since most of the other chapters are just like about the book or about the authors. So the first major chapter is art basics. So it's expected for us to have gone through that particular chapter before the session. And I hope most of us have already done that. So I don't know if we can just briefly introduce ourselves. So let's just get to know more each other. Just some few minutes, just your name and just where you're coming from. So I don't know. Let me start with Karen, if I pronounce it right. So hello, Karen. Please, can we know you?
Good afternoon, everyone. My name is Karen, and I'm joining from Kenya. Thanks.
Okay, I'm not hearing you clearly. Sorry, please.
Good afternoon. Am I audible? Kindly confirm that I'm audible.
Okay. Yes, I'm here. I can listen to you now.
Can you hear me?
Okay. Yes, I'm hearing you now. I'm hearing you now.
Okay. My name is Karen Colley, and I'm joining from Kenya. Thank you.
Okay. Okay, thank you. Okay, let's please Joshua Hodinya. Okay.
Yeah, my name is Joshua Hodinya, and I'm joining from Accra, Ghana.
Okay, thank you very much. Okay, the next is Mr. Lukman A.
Okay, good afternoon. My name is Lukman Aliyu. I'm joining from Abuja, Nigeria.
Okay, thank you. Then thank you very much, Mr. Lukman. Next is Rasha El-Nimeri.
Good afternoon for everyone. I am Rasha El-Nimeri. I'm joining from Egypt, Cairo, Egypt.
Okay.
Nice to meet everyone.
Very nice. Nice to meet you also. Next is Mr. Stephen Aka.
Yeah, good afternoon, everyone. My name is Stephen Aka. I'm a field epidemiologist in Nigeria, but I'm currently in Japan. So I'm joining from Nagasaki, Japan. Nice to meet you. Thank you.
Nice to meet you too also, Mr. Stephen. Okay, thank you very much, everyone. Nice to meet all of you, and we hope we get to learn from each other. So I've already explained earlier how the study group is. It's not like it is a training session, so we're expected to like discuss between ourselves, go through the chapters of the books. So each person in each session, an individual in the session will actually go through the chapters for us, but it's expected of us before that particular session. We have gone through the chapters and see what is in the session. So we discuss about the chapters and get to learn more from each other. So that is one of the reasons why we are here. So we're all here to learn from each other and also share ideas of each other of our various experience and our various experience in using R, and also get to know more about R from each other. So the first chapter in this book is R basics. So even though you're already experienced with R, I'm very sure this will be like a refresher. And if R is new to you, then this chapter will let you get started quickly. So it's just talking about the basics of R. So first of all, the first section is why do we actually use R? So what is R all about? So we already know R is known as a statistical programming language, but in recent times, it's actually gone beyond that. So R now currently, you can even use it to build web applications to actually show your data or allow users or clients to interact with your data, to present your data. It's also used in machine learning and deep learning. So you can see that in recent years, it has gone beyond the usual just statistical analysis and things like that. So it's obviously used to build complex applications too also. So it can compete with other programming languages too in other fields and even web apps. So why do we actually use R? So though we know that we use it for performance statistical analysis to analyze our data, but also if we want to retrieve data from heavy systems or want to build machine learning models, we use R. We want to build web applications that you can actually use, want to use web applications. So it's not just enough for us to just analyze the data and maybe put it in a PowerPoint slide, or maybe we just write a text or a report about it. So we can actually create a dashboard, an app, which a user can interact with. So when a user interacts with this application, they can be able to, interact with some of the variables in the data that we have and know that, this is how the data changes, or this is how the plot changes based on these particular changes that the user is making. So this makes more sense than just giving someone just a report or just a text of just what I've already analyzed or things like that. So, and also R is free to use, it's open source. So there is, unlike some closed proprietary software such as SAS, we have Stata, we have SPSF. So these are also tools that are actually used for analysis, but they're actually proprietary. So which means you need to pay for it to be able to use that particular application. So R is open source, and because it's also open source, it means it's contributed by a lot of developers outside. So a lot of developers contribute to it. So every version that you update or every version that you download is actually fixes that have been made on it by people from the open source community, and it's actually free for you to use. And also reproducibility. This is something that also some applications too don't have. So it's not a pointer and click interface. You have to write a script to run your analysis or run the program that you want to do. But the thing is that for a point and click interface now, it will be difficult to reproduce it. So something like Excel, imagine now conducting an analysis of that took you 5 hours long, and someone wants to now reproduce it. How do you do that? You now need to start explaining that, you click on that, click on this. But in R, you just have your script already. Once you just explain to the person that this is how the script works, then that individual will just run that particular script and also make changes where necessary to the scripts. Then also in terms of community, so just like our own tool also that we have here, Abuja User Group. So this is just one of the many communities that we have in R. We have the R Consortium, we have the R Ladies. So these are various communities. So the communities are very strong. So we learn from each other and also contribute to R on itself, because even the developers that contribute to the R also belong to some of this particular community. So some of the key terms that we have are R Studio. So we have R Studio. R Studio is more or less, though now it's no more R Studio, it's actually called POSIT. So due to the support for Python and also other programming languages in it now. So formerly it was called R Studio. So it is more or less like an IDE, integrated development environment. So a GUI that allows you to be able to use R. So R itself is the main programming language, while the POSIT or the R Studio is the IDE. So you can actually use R itself, but you cannot use R Studio without the R. So which means that for the R Studio, for it to work, so you need to install R. But you can actually use R itself, but one thing that makes using the IDE, because it makes you more efficient and fast. So the R is difficult to do some analysis in the R that is without some of the help that the IDE will offer to you. And also we have what we call objects. So anything that you store, normally in a programming language, anything you store, some people call them variables, some people call them objects. So, but in R, we call them objects. So everything you store in R, data sets, variables, or lists of items, or the data, anything that you just have that's already stored in the memory of R is called an object. And they can be referenced based on the name that you give that particular object that you have already created. Then we also have what we call function. So function is a code that actually performs the operation for you. So normally R comes with its own functions, but you also, when you have a task that you want to perform, and you can see a function that can perform the task for you, then you have to create your own tool also, which you can also share with others. Then also have packages. An R package is also like a group of collection of functions. So an R package is a collection of functions which someone can use, or you also yourself, you can use later on in the future. If I have a group of functions, instead of just calling them one by one, I can actually bundle them in an R package. And that's why you see you have a lot of R packages online. So these are just collection of functions that people also other use. And we have scripts. A script is a file that holds the command. So this script you can actually share with someone to reproduce an analysis that you have already done. So the resources for learning, we have various resources for learning, but the major resources are the main resource is actually documentation of every package that is produced. So a documentation is just how to use a package, and that documentation is usually created by the developer of that particular package. So let's say, for example, now a library that is performing a task on a regression modeling. So we have a package that is doing that particular task. So the developer that actually created that particular package will also write a documentation for it. So it's this documentation you refer to when you want to know how do you interpret your analysis, how do you do this analysis, how do you do some particular tweaks inside the function. They will have various interactive tutorials too also. So one of them is previously used to be Swell. A lot of people used to use Swell, but now also have LearnR. They're actually interactive ways of learning R too also inside the R Studio environment. So we also have cheat sheets online. So cheat sheets are very important because it's not easy to just, some of these packages have a lot of functions. So it's not easy to just memorize these functions. So we have cheat sheets which can actually look at each or most packages that are actually popular, like some of these dplyr, stringr, lubridate, forecast. They actually have their cheat sheets. So you can just go online, just search for the library and the cheat sheets, and you will see it online. So though when we start going through, and I'm very sure most of us will just see some of the links to the cheat sheets inside the book, so we can just go online and search it. And so these are some of the community handles that we have on Twitter. And also these are some of the online resources. We have R for Data Science. So there's a study group for R for Data Science. I think this was the study group session was conducted on Wednesday. So this based on this particular book also. So now I'm not sure if all of us already have R installed. So, but if you want to install R, this is the site to install R, and this is the site to install R Studio. So let me just open it. Okay, are you still seeing my screen? Hello?
Yes.
Okay. Okay, hope everyone is with me, right?
Yeah.
You're following.
Okay. Okay. Okay, I'm just trying
For now, yes.
Okay, are you with me?
Yes, sir.
Okay.
Yes, we are.
Trying to. Sorry, please. I'm just trying to hide this Zoom bar. It's preventing me from going to my browser tab. I'm coming, please. Okay. So this is okay. I think you are seeing my screen now, right? Okay. So this is the R. This is where you can download R. So you can see it. You can download R here. If you don't have R, you just download R. So this is the first thing the first step you do. You download R before you now go to download R Studio Desktop. So this is it. I can download R Studio Desktop for Windows. This is for Windows. So if you are also using maybe your Mac, that's also support for Mac and other OS or Linux. So you download the R before you now download the RStudio. So, and when you download it, this is how the interface looks like. So you can see it. This is how the RStudio interface looks like. Okay, so let's go back to the book. Okay, so we have some softwares which are also very important when you actually install your R and RStudio. First of all, we have what we call TinyText for compiling compilation of R Markdown. I'm not sure if you have heard of R Markdown. Any of us have heard of R Markdown? Hello. Hello. So okay.
Yes, I have.
Okay. Are you people with me? Okay. So have any of us heard of these particular tools that you are seeing here? TinyText, Pandox, R-Tools, and PhantomJS? Okay. Are you guys with me?
Yes.
Yes,
Okay.
we are.
Okay, so I'm asking, have any of us heard of any of these particular softwares that is here, these four?
Yeah, I have RTools.
Okay, R-Tools. Okay, so what's this actually used for? Can you please share it with us? Okay, we are hearing you. The R-Tools. So what have you actually used it for? Hello, hope I'm not breaking. Hope my line is not breaking. Hello?
We can hear you really. Yeah.
Okay, no problem. So TinyText is actually for compiling R Markdown document to PDF. And we have Pandox for compiling R Markdown documents also. So, and we also have R-Tools for building packages. So if you want to perform some of these tasks in brackets and you don't have these tools, so we are not actually going to be able to achieve your aim. So these are like other softwares which you might need to install. But sometimes some packages also install them directly. So some packages can actually install some of these R-Tools and Pandox for you. So this is actually the code for installing a package. So this is an example of a function in R, install.packages. So you can see we have TinyText. So I have to just go to my IDE. Let me just copy this. So this is my IDE, and this is where the script is actually written. So we'll go there in a moment. If I should just paste this here and run the script, it's going to install TinyText. So also have Pandox, a document converter. It's also a separate software from R. But because you have RStudio, it comes with it. You don't need to download it. So it also comes with RStudio. And we also have R-Tools. And we have PhantomJS, usually used to take screenshots of web pages. So these are some of the applications that are also necessary when you're using R. So now let's just go through the RStudio interface. So the RStudio actually have 4 windows. So let me just some coming. What's that funny? Yeah, I'm trying to open this particular window on the console. Okay, we have 4 windows in RStudio. This is called the editor. So you can say call this the script editor. So any script you have, this is actually where you type it on this particular script editor. Just as I've already pasted this sample text here. So, and the other one is also where we have our environment. So actually this one contains the environment, the history, connection, tutorial. Most of the times it's just the environment here. So any variable you create, any data you load, any object you have already created that we explained earlier on objects, you're going to see all your objects here. So for example, now a simple way of creating an object is just to say A is equals to 2. So this is usually called, this is the object name here, which you are seeing A, which is on the left-hand side. And this is the data that we are storing there. So I can just use run. So you can see by running it now, I have this is my objects that I have in this environment. So this is just an environment to show you any object you have loaded inside R. So even from this window, you can actually know, and it's even the size. You can see when you highlight it, like it's telling you the size 56 bytes, numeric. So you can see it's telling you that A is numeric and it takes 56 bytes of the memory. So with this, you're able to know what objects are actually inside your environment and what objects you are working with. This usually comes handy when you are working with a lot of objects. So the next also is the, I'm trying to open, okay, I think it has come, the arrow. Yes, okay. So this other one now is called the console. So this window is actually with the terminal and the background job. So most of the times it's the console you need. So just the same thing I run here, I can actually run it also in the console. The only thing is that anything I type in here, I cannot save it. Unlike this script, which you can actually save, just like you save your Word document. So anything I type here, just go into the console. It's not actually like, though the object is saved or created, like I can just say B is equals to 4. But the problem is that I cannot actually save this code that I did. So you can actually use this console for rough. Let him just put it in the times like a rough work. We want to do a rough work or just to see how code works. You can actually use this particular console. And most of the times, so also your output to also shows here. So I can use a function called print, which prints objects out for me. I can say print A. So you can see, unlike the script, which doesn't show output, the console actually shows your output. You can see it's showing me 2. So that's console. The console is also with the terminal. This terminal comes in handy when you actually want to work with your, let's say you want to work with your operating system, or you want to work with other you want to work with, just like your CLI. So for example, now you want to work with Git, your Git repository online. So you can actually use the terminal to work with it. Also, you want to work with your operating system. Like you are saying now, this is my main directory now, users. So this is where my main directory is. So this particular portion of the window actually covers. And then we also have the files here too. Most of the files on your PC will also show in this particular window. So we have the files, we have plots, packages, they're all together. Most of the times it's the files and the plots. So anytime you plot, which we'll see later on, the plot's actually going to come out from this window, this plots window.
But your funding non-stop.
Okay. So though this position of the windows are not actually fixed, you can actually change it based on your own preference or settings. So you can actually change this yourself. You just change your own window settings, but these are just the 4 windows that we use. So the position can be in anywhere based on your settings. So, and the settings is actually here. You go to tools and you go to global options. So you can see some of the settings that we have. So you can see all the settings we have. We have general settings. So under the general settings, we can see some of them are not settings that you might not even you might not need to touch it. But most of the times, this is usually important to always put this as never, R data on exit. So what this does is that anytime you close your RStudio, any object you create, so it's not going to save it into your workspace. So it's usually very important to actually put this on never. Most of the times when you install RStudio, it's always on always. Or if you also want it, you can put it on Axe. So what happens is that when I should close my window now, if this should be on always, these objects are not going to be cleared from the memory. Even if I shut down my PC, at times it will come back. You are going to see it when you start R back. So more of the times, it's a good practice to always put it on never. So just make sure you have your script saved. Once you have your script saved, even though you close your PC, you can run your scripts and your objects you can end up creating your own objects back. So you don't need to be saving your objects again. So we also these are just some of the settings that we have. So these are settings that one can actually play with. actually play with it. So you can see we have GPU. That's if you want to use perform deep learning tasks, which actually uses GPU. So these are settings that actually take care of that. Then we also have the code settings too. So your tab widths, these are your code spacing. How do you expect them to be? And anything that just deals with the script or the code editor is actually talked about in this place. So I have one part that I want us to go to. I think that should be, let me see. I had the pipe operator. So the pipe operator, though, I will come to it later on in the chapter that talks about the pipe operator. But you can actually set, normally the pipe operator wasn't actually created in R. So it belongs to the dplyr, I think is the dplyr package. I think it's the dplyr package. So the pipe operator was actually created. So with those set of packages. So later on, because of its popularity and how people use it, so it was later used inside, like built in the recent versions of R. So we call that of R the native pipe operator. And this is looks like, native pipe. You can see it requires the version of 4.1 plus for it to be able to use the native pipe operator. So most of the times, if you want to use native pipe operator, you keep this checked on. But if you want to use that of the other packages, that is the other packages looks like this. So I think it's a shift%. Okay, this is native pipe operator, shift%. I think shift%. So I think that of the other packages looks like this. So if you want that of R, you can keep that actually checked on. So most of these options are something that one can actually play with. Appearance, you can see the appearance, you can change your appearance, how it looks like, your theme, that is Korean, you look like, just based on what is comfortable for you, you can choose it, and even your font size. And this was the pane layout I was talking about. So if I should take this to this place now, okay, I think, okay, just click on here. Okay, let's say I want to swap the position of console with that of source. I'll just come here and click on console, and I'll click on source and make it, okay, I'll click on source and make it console. So because I've swapped it with console, it's going to automatically change this to source. So once I say okay, you can see that the position has already been swapped. The terminal is already here and the editor is already in this place. So these are just custom things that you can actually do, that one can actually just do to just make the IDE comfortable for the person. So we have other, this is support for Python. It's actually support for Python. If you want to add your interpreter, so interpreter actually means the Python executable that you have already downloaded from their site. So if you want actually Python to work, so you need to add your interpreter. So it's going to find interpreter for you. Currently, I have none selected, so it's going to find the interpreters. And once you is able to find the interpreter, it's going to add the parts. So once the part is already added, it means you can actually run Python code inside the RID. So you can see the two interpreters I have. So you can see them here. So any of these particular parts, I can just select one, select. So you can see. So that means you can actually use Python code or write Python code inside your RStudio IDE. So this is one of the improvements that I made in recent years. And I already made the IDE now to be multilingual. So it's not just only R, you can actually use Python with the IDE. So,
sorry, can I ask a question?
No problem. Your question is welcome.
Thank you, sir, for the presentation. I just wanted to confirm this Python integration into R. So if I want to use Python in R, I have to activate this button you just showed.
Yes. You have to select your interpreter. So yes,
okay.
Just download Python. Once you download it, you just go to your global options and click on this Python and just select. It's going to search for the interpreter wherever it is on your system, and it will automatically add the parts. So you can see this is the executable downloaded online. Then you can be able to run Python scripts online inside your IDE.
All right, yes. Thank you.
You're welcome, sir. Okay, so that's it. Then we also have the file. If you want to create a new file, so most of the times you might be creating new projects because if you're having if you want to analyze, you have a work that you are doing, so it's very advisable to have a project for it. So creating a new project means like you are creating a folder. So which means anything you create your script, your data is going to be inside that particular folder. So for example, now I want to conduct a, let's just say a survey, and let me just say I'm conducting a survey. So I can just say new projects, and okay, don't save. So you can see it's creating a new project. So you can see that we have under create new project, we have new directory, we have existing directory, we also have a version control. So new directory, it creates a new project for you. So let's just go to new directory. So under new directory, that you can just create an ordinary new project, just say an empty folder, or you can create an R package. That's for someone that's building an R package, is going to just go through this particular part. That made everything easy for you. So this is just like, how will I put it, a generator that already generated the necessary files that you need, or the necessary file arrangements you need for that particular project. These are just an empty folder, but most of these other ones here are generators already. They have everything set up for you based on what you want to create. If it's a China application, you see the files already created there for you. The files that you need to create the particular application, you only just to go to each file and put the necessary code inside to make it work. So most of the times, if it's just a normal project, you just go to new projects and you just put your directory name. You can also put the name of the directory, because we're talking of a folder now, not a file. So that is why you need to put your directory name. Then we'll also have the subdirectory. That is the project you want to create is under which particular directory. So this is under my documents. You can choose it based on what you want. So then the other options, we have existing directory. If you also already have a project already and you want to join another project with it, you can use existing directory. Then we have version control. So this version control, when you have a repository already from Git, so you can actually use this version control. You can see it clones a project from a Git repository. So there's actually a command for this, but this is for those that prefer to use the graphical user interface, so it makes it easy. So just put your repository URL here, and you put the name you want it to be on your local system. So it just clones that particular repository for you on your PC. So this is what the version control actually does. So this is just to make setting up a project easier. So I can just go to new projects. I can just say I'm converting a survey. So this is just a survey on under 5 children. And if I want to create a Git repository, I can actually check on this. And also, if I want to use R environment with this project, I can also check on this. So these R environment is just an option of if you just want your packages to be installed for this particular project. So which means if you install a project in this particular R environment, once you are not in that project, it's like as if that particular package is not installed inside R. So I just say create projects. Okay, so you can see now that this is a project. This is a project that's already created. That I've already created. So you can see this particular file here now. This icon here means that anytime you see this, even when you go to your file, manager, that is your Windows file folders file editor, you are going to be seeing this sign or this symbol. So anywhere you see this symbol inside a document, even online, you might see the symbol. It means that that particular folder or directory is an R project. So this is what this sign actually means. So automatically, all your directory here, any file you create using this file, new file, anything you create is going to be created under this particular project folder. You can see most of the files that we can create in R. So R supports a lot of languages. It supports Python script, it supports JavaScript, Notebook, we have Quarto. So these are a lot of files that you can actually create inside R. So this is very interesting. And also, when you want to open a file, you can use this command open file. So most of these are just like your basic file. These are your basic file operations: creating, opening, deleting, or closing files. You also have the edit. So this usually deals with the scripts editor. Most of the times, I'm going to just be using the file. Most of the times, it's just the file you'll be using. Some options are actually available just by right-clicking. I think, and to swap this back. Okay. So now these are our out script, and as earlier on I already showed us an example of just a simple code. A is equals to 4. So this is it, though it's untitled now, which means that it's not saved. So you can actually just see Control S, and you can see I can just save it now. I can just say scripts. So you can see that by saving it as script, it already appeared under my files directory. You can see it's script.r. So this is it here. It's under this directory. A is equals to 4 is the just a sample code. So we can actually use this particular button to run it, or you can use Control Enter. So even by highlighting on it, you can see that it's showing us a hint that run the current line of selection using Control Enter. So you can use Control Enter to also run it. It's a shortcut, and you can also just click on this particular run. And also have what you call source. So this is like running all the scripts that you have inside this particular document. It runs like similarly also with the run. Most of the times, if you have like 100 lines of code, you just use the source button, it runs everything. But for the run, you can just run a specific line, maybe 2, or just highlight some lines and you run that particular script. So also have other tabs, like we have the view tab. This is just to customize your view. If you want to increase it, like zoom in, or want to zoom out. So these are things that one can also explore on his or home. Also have plots, we have session, we have build. So most of the times we usually just deal with the file, and any other option you might see by just right-clicking, or maybe right-clicking on your file, or maybe some options in this place. Okay, so going back to the book now, we also have some keyboard shortcuts, as you can see them here. So we want to escape. Escape is usually used on the command line. So you want to escape a particular command that is already running, you just use the escape. We have Control S for saving. We have the tab for autocomplete. So most of the times, if your function name is long, for example, now we have a function called filter. So by just typing FI, you can just use your tab to complete it. You don't need to type the remaining text of the particular function. So we have the Control Enter. So for running current line of selection of code, I just talked about this. We have Control Shift C to comment or uncomment the selected lines. So we have Alt minus to insert this. So this is the assignment operator. I just used the equals to earlier on. So I just used the equals to earlier on. But this is actually the assignment operator that is encouraged to be used in R. So I just use the equals to earlier on for, I don't know, maybe someone is just new to R. So, but this is actually the assignment operator that we actually used in R. So this is called the assignment operator. So the shortcut is actually Alt minus. So you don't need to be typing less than and minus. You can just type less than and minus, but the shortcut is using Alt minus. So this is how you actually use the assignment operator. So also for the this is for the pipe. So Control Shift M. We want to clear the R console. We have Control I. We have also, we want to run start from the current line. You have Control Alt B. So these are Control Alt T for run the code section, R Markdown. So these are something that you can just, if you prefer to use the shortcuts, you can be trying them, you get used to it. And also, if you just prepare to use the interface, you can still use your arrow keys to just navigate it. So now the next section is talking about functions. So functions are the core of using R. So functions is just something that takes an input, does something with the input, and gives out an output. So that's just what the basic thing a function does. So the common function that we have is usually print. Print is a very common function. So I just say A is equals to 2. So you can see print now. What print just does is that it takes an object and gives out the value of that object in the output. So you can see that print gives out 2. So what a function takes is called an argument. So, or sometimes called parameter, is used interchangeably. So a function takes an argument. You can have one argument. Sometimes some don't even have any arguments at all. That means you can just call the function like this. So this is just an example. You can call a function like this, which means no argument is needed. So arguments can be needed, or sometimes it can be optional. So some functions can have one argument, some can have two arguments, some can have three. It depends on the role of that particular functions. So you can see that the print is just a simple example of an function. And the example they give in the textbook, we have square root of 4. You can see that square root takes a number and gives out the square root of that particular number. So this 4 now is the argument of the function square root. So, and also you can check a function using the question mark and the function name. That's if you want to check a help on the function. So by running this now, you can see that it's going to give you a documentation of the function. So for example, you have a function and you want it to do more than what it does. Maybe there's some arguments you don't know about. So you can use the AI to check the optional arguments. But for this function that we're taking now, square root, it takes only a single argument. You can see it takes only x. So you can just use this particular square root function to take the square root of x. So these are the arguments. You can see the details of the function, also the references. Maybe you want to publish a paper and you need to include the references for the functions that you used or the package that you use or libraries. You can see the references under here. And you can also see examples which can run. These are examples that shows you how the function does. So most functions, if not even all, usually have that particular help. We can do that on the prints too also. So this is for the prints. So you can see the description. You can see the print values. This is the description of the print function. You can see everything about the print. So for the print function, actually I have a lot of arguments. You can see them. So you can go through the argument and see that, okay, this is what it does. Then you add the arguments. Some arguments can actually take a numeric value. Some can actually take a character. So character or string. So some arguments can take characters or string. So like, for example, this is a string. While some will take a numeric value. And some are just general. They can take anything. Like this X now can take anything. It just take an object. So that's what this particular X does. So this is an example of a function inside R. This is how it looks like. So I think we have already talked with function with multiple arguments. So you can see it here. This is an example now. So they just gave a diagrammatic example now of a function called ovenbake. So let's say ovenbake is a function now. Ovenbake is going to take dough, which is the first argument. And also this argument have to be in their positions. This is another important thing. They can only be scattered, for example, if you are giving the name of the argument. So this is, for example, now this is minutes I'm using now. Minutes is equals to 45. Temperature is equals to 165. If I'm giving the names of the argument, I can actually arrange it anyhow. I can put minutes to be at the last. But in situations where I'm not giving the names of the arguments, so I need to arrange them based on the way the arguments are arranged when the function was defined. So most of the time, it's a good practice to always give the name of the arguments. You can see minutes, we have temperature. So these are just the argument optional. These arguments at times can even be optional, at least 2, or sometimes it can just be compulsory. That means you have to give it for the function to work. You can see our assignment operator and you can see the function that was created or redefined. So this is also another example here. Create an H pyramid. So I don't know if I can run this. Let me see. Or it needs a package to run. Okay, so I think it's just a sample. It's just a sample example, or I'm very sure, or maybe it needs a library that's been installed. Okay, so this is an example now of a function H pyramid now. So this what this function actually returns is a plot. So a function can return various things. A function can return a plot, some can return objects, some will not even return anything. They will actually perform the tasks in the background. So some functions will not do anything. They will just like perform what they want to do at the background. You will not see what they are doing. Why some will return tables, why some will actually even save your data, interact with your file system. So this function is H pyramid. It takes the arguments, data, age group, and splits by. So the data is going to be your data that you are going to use. Why the age group is just going to be the variable that you want to group your data by. So that means it's taking your age group, and why splits by. So after taking your age group now, then that group it takes, what should it split it by? It's going to split it by gender. You can see it here. So it's all these that I give you that are going to make this function to return these plots. You can see our gender here, male and female. You can see the pyramid, and you can see our age group here. You can see our age group. This is it, which is on the y-axis. On the x-axis, we have our counts. So this is how functions work. So some of these functions sometimes is you will create it yourself. Maybe not see what the function, what a function will do for you. And at times, you can see what you need from a particular package. But it's a good thing to always check if there is a package that already has the function that you want to do online. So to avoid reinventing the wheel is a very good practice, because sometimes these functions are long lines of code or scripts. So a function that looks like this, you might see that it takes long to just be able to create something. So always try and see if there's a function that actually do what you want. Then from there, you can now know whether you create yours. And if you create yours, it's also a good thing to always share with others to also help other tasks easier. So that's why we're able to perform some of these tasks. So at times when people create functions, they share it with others so that people can be able to use it to perform their tasks when they need something like that. So this also are the function too also. So it's still the same function, but this time around, so these are just various ways of like writing, these various ways of typing your code. Still the same thing, but if you look at it now, you can see that this one looks more easier to read because each particular argument takes a line. Though this one will take longer lines of code, but it's easier to see it. And this is very important when it comes to debugging your code, because if your code is just clustered, your function can be very long. Now, this line of code now, you can see is going to be very important for my window here. You can see what's happening here now. I cannot see some arguments in just one scene or in just at a single site, but you can see from here now, I'm able to see all of them. So these are various ways of typing your code. So most of the time, the good practice to always type it like this, is inline listing. But at times, you can also use this format if you are just interested in maybe, or if your arguments are not much, like that print or something like just taking only one argument. This is okay. You can actually use something like this. But it's also preference. So it's based on you. So this is also another
Sorry, I wanted to ask a question regarding the function, identifying a function whether it's already existing before you bother creating a new one.
Oh, okay.
So how will you be able to do that if you don't know the package where the function exists?
Yes, what you can actually do is that if you have a task that you want to do, so let's say, for example, you have a function that you want to just do something. Okay, you can just say you have a function that wants to plot a heat map for you. Okay, I need a function to create a heat map. So you can just Google it online, R function to plot heat map. So most of the times after your search, you now see that you are not able to see that particular function. Because sometimes when you Google something like that, you actually see the function inside your search results, or you can see a package that is doing that particular that can do that particular work for you. So, but most of the times, what some people also do that they don't even bother to just search. When they want to do something and they cannot see something that will do it for them, they just go directly to just create, because some functions might not take you time to create. They just go directly to just create what to do what they want, and they just use it. So, but at times when you just go online to search and see which particular function is doing this particular task now, like something now, for example, now this function now, though I don't know if this belongs to a package, so you can just go online and search, okay, function to create H pyramid output. So if you go online now and see this function, because at times if you search the function name, like if I should search for this now and it actually exists, so I can just see the result out. And once I see the results, I will be able to see it with the package that is there. And also you can use this way, or also maybe someone talks to you about a function to see if you can get a function. For example, I can see H pyramid. So you can see what it's telling me now. No documentation for H pyramid in specified packages and libraries. So you can see that, which means this is not existing in my PC. There's also another way too also. There is this site. Let me see the site. rdrr.io. I'm coming, I think. So this is also another site that you can use to search for function names to see if there's a function that exists. So I can just say H pyramid. I don't say search. So you can see that. So this is the function, I think. So I think this is the function that we're using. So you can see the H pyramid function. So at times you can just search a keyword. It's not necessary to be the function name. You can just search a keyword based on what the task you want to do. So if your keyword comes out with the result, you can try the functions or packages you see. So each of these functions, I can see they have their respective packages now. I think this one is this particular package. Here is it, individual based model population simulation. And this is also the package for this one. So these are various packages that are having this particular function H pyramid. So you can see it. So I don't know if that's clear, sir.
Yeah, I think it's clear.
Okay.
Thank you.
Okay. You're welcome. Okay, so now this is also another example too also. So this was what I was explaining earlier on, where you can, it's not necessarily you give the argument names for some form of your function arguments. But you can make sure that if you are not giving the argument names, then they are arranged based on the way the arguments are arranged in a function. I cannot bring gender to this place and bring age category 5, age cat 5 to this place. The function is not going to work. But if the names were there, the function can still work because the function already identified them. By not giving the names, the function is going to identify them based on their order. So that's why it's very important you place each argument in the position it's supposed to be. So you can see that this is also the H pyramid now with additional arguments. We have proportional, true, we have PAL. This PAL is going to take in, so arguments take more than one value inside a vector. So we call this a vector C. So this is it, call it a vector C. Okay. So now writing functions too. So I already explained all about writing your own functions too. You can actually write your own functions and also create packages out of them. So packages contain functions. So most packages are in fact made up of functions. Though some are made up of data sets, but even the data sets, to call them at times in this package, you also need a function. So most of in fact, packages is just all about function. So once you have a package, it's a collection of functions. So of a lot of functions or maybe that are related to each other. And also to install a package, you need your install.packages command. That's the particular command we used earlier on, install.packages. And also, if you want to, for example, now, let me go back to this. Let me see if. Okay, this is a package now called. So this is an example of the tab. You can see that I just clicked on tab and the function, how the tab works. So you just click on the tab and it's going to bring out the function that you want to use. So install.packages dplyr. So it's going to install the package for me. So this is the first step in installing a package, install the packages dplyr. So though I have it already, not waste our time. So I already have it installed. So let me just cancel this. So if you want to load it now, use library. So packages are a collection of functions, while library is where these packages are stored on your PC. So this is the library. This is your local library. You're going to call this. It's just like telling R that, okay, I want to make use of this package, make it available in the environment. Because of space, that's why you cannot load all your packages inside your environment. So you need to be calling the particular package that you want to use. So I'm going to say library dplyr. And by using library dplyr, I can see that it's already loaded it for me. So I can use any function from this particular library now. So a typical function that we can use now is the filter function inside dplyr. So by calling filter, two functions can be in different packages. So this is where you can know the package that a function belongs to. This particular curly bracket that you are looking at here. You can see another filter too also. This base means that this function belongs to base R. You don't need a package to use this particular function. That is what base means. If, for example, I have a package now called lubricate, then you can actually see that function under lubricate in this place. So I'm going to just take note of the curly brackets because sometimes packages might be different, but they have similar functions. It's possible. But no, I don't think any function, any package can have the same name. So no two packages can have the same name, but they can actually have the same functions inside a package. So most of the times we install from CRAN, Comprehensive R Archive Network. So most packages are installed from CRAN, except maybe if you want to install the development version of some packages, you can install from GitHub directly. So install from GitHub is different. That's also another way of installing from GitHub. It's also different, but at times most of packages install actually from CRAN. So, but most of packages on CRAN have already undergo testing. So it's always good to install packages from CRAN that have already been tested, and you are sure that when you use it, you have no problem, and you don't need to worry about any virus or security issue when you use packages from CRAN. So it's very important to always install packages from CRAN. And when the packages are updated, you just need to call install the packages again, and it just updates the package for you. So it's not a long process. So you can see it here, how to install and load. So this is another command that allows us to what? Install necessary packages here. That is packages that we don't have. Pacman pload. So we use Pacman pload to install or load packages that we don't have. So what this does is it does like a two-in-one work. So what it does is that it checks if you have the package, and if you don't even have it, it installs it and loads it for you. So we have Pacman pload. So you can actually use them and put all your packages there. So this is usually used for someone that maybe you want to share your script to someone. You can actually just put the command at the top. So the person runs it, he checks to see if the person already have the packages for the functions that you are using in your script. Why this one install the packages but does not load it? You can see this is the popular one that you can actually see most of the times installed with packages. It only installs the packages. I want to install multiple packages. You use this C command. We call it the combine command to just combine it. So you can install multiple packages using this particular command. And if you want to load it, this is what you actually, so most of the time, this is just like a shortcut, this Pacman pload. So it installs and even loads the packages for you. Any package that I don't have is going to install it and load it for you. So this is also the installation from GitHub I talked earlier on. So most of the times, packages that are not yet available on CRAN, or maybe they're still on development, you want to install the development version, you can actually use install from GitHub. We also have installation from zip or tar. So this is the GitHub code, pload gh. You put the GitHub, you can put the repository name here. So most of the times here will be the name of the author of the repository, and here will be the repository name. So this, you just use this particular command. Most of the times it's always good to make sure that I've already signed into GitHub, and also you have signed into to Git. So it's also use the same pacman command to actually do that particular task. So if I continue, is there any questions? Okay, hello, are we there?
Yes, I'm following.
Yeah, we are here.
Okay, is there any questions before I can continue? Okay, I think let me just continue, no problem. Okay, so this also zip for tar. So most of the times we also have this way of installing packages. Most of the times, the one you just be needing most of the times is just these particular ones, especially these ones, and just these ones. So, because it's always good to just load your packages from CRAN for security purposes, especially. So update packages, you don't have to be updated. You can update packages by just reinstalling them. So you just, and also there's another way of actually checking packages. I think these packages here. So this particular tab in this place is your packages. It lists them for you. All the available packages that you have, it lists them for you. You can see all the packages I have on my PC. All of them are on this place. So I can use install to install them. To install a new package, I can use install to install a new package. I'll just give the name. So okay. I just say dplyr. Okay, I think dplyr is already installed. Let me see. So I can just click on install tiny text, and it's going to install it for me. So it works just like this same particular code that we used earlier on. Then we have updates too also. Okay, I think you need to select. I don't know what's happening. Okay. I don't know what's the problem. Most of the times, if you just want to update your package, just call this installer packages with the package name. It's just going to give you the newer version from CRAN. It's just as easy as that. You can use it to install your packages. And most of the times, it's always good to also not to install much packages because of space on your PC. So just install necessary packages that you actually need and you know they are going to be useful to you. So most packages also have what we call dependencies. So that means some packages are built on another package. So a typical example of that now is something like, let me see a package that, okay, for example, now you want to build a Shiny app now. So the Shiny app, or how a typical example now is the R2 we talked about earlier on. So the R2s now, you want to build a package now. You cannot build a package without using R2. So if someone is going to use a package now on his PC and doesn't have R2 installed, he's going to be having a problem in using that particular package. So that's why most of the times you even see that the top that they put is necessary to install those particular packages. And this is what I talked about earlier on maxed function, that two packages can have the same, two functions can be in the same package. So you can see that filter, this means conflict, that two packages are having the same function name. So they call them max functions. So this is just what I explained earlier on. Now one has to be careful of that. So, but a very good way of handling that is using this code. Is using dplyr filter. So your package name comes first, then these two columns, then your function name. So this is a very good way of using functions that are usually conflicting with another function conflicting functions in another package. So this is a very good way. Once you do it like this, there's not going to be any conflict. So you can detach a package using this command, using the detach package name here, unload is equals to true. So this is actually a way of detaching your package. So if you don't want to use a package again, you just use the command detach with the package name here. So I already talked about scripts too also, which are where you actually type your code, where you want to share it with others, that's reproducibility, also for portability and version control, and also for commenting, you want to explain to people. And we have what we call comments. So this is an example of a comment. So a comment is just a line of code that is not executed. So this is it. So you can just, comments can just be like data sets. And just, you can even use that as an outline, model, output, export. So you can use it even for outline. And under each comment, you can type the codes that are going to do, that you want to execute under it. It's just like an heading. It's like an heading for a script. That's what a comment is. So this line of code is naturally executed. So for example, now if I should say comment x is equals to 2. So if I should run this now, you can see that nothing comes up. It just runs an empty line. So that's why it's usually what's comment. So, but this one that actually run is because this particular one is a code, while this one is just a text. But still, it just takes it as a comment, not as anything serious. So it's just a comment. So which means it's not, you cannot even see it in your environment. And also style of, we have what we call style of your coding style. So various people have coding style, but always go to, it's just like an handwriting when you're writing. Your coding style is your handwriting. So the clearer it is, the more easier it is for people to collaborate with you and also work with you, or people to even review your code too also. Some coding style are very bad that it is a very simple code at times, but based on the person's coding style, it's going to be very difficult to read. So, and also it's good to always use linter. So a linter is something that actually creates space for you. So there are packages for linting in R, such as styler and linter. So once you install this, it automatically lints, even though you have a scattered code, you can actually automatically space your code. For example, now, this now, you can see I can actually create spaces between them. But if I have various lines of code or I have a bad code that I need to review or work on, I can use a linter to adjust the code and make it more readable and understandable. So coding style is very important. So next we have R Markdown. R Markdown, though R Markdown is usually used, now we have Quarto, but some people still use R Markdown. So R Markdown is a document that allows people to write your R script and also write text together. And you can export this document into PDF, HTML, or PowerPoint, or Word. So this document contains code and text. So this is an example of an R Markdown I just say file, new file. You can say R Markdown. So you give the author name and you give the title. You can just say sample reports, and which output do I want? Is it PDF, Word? So most of these exporting options, they need a particular package. They need text. You can see this one needs text, and for you to be able to export to PDF. So I can just put HTML and I put OK. So when you create a R Markdown, it gives you a sample document. So this is an R Markdown document. So if I should just say neat to HTML. Okay, let me save it first. So if I should say neat to HTML, so knitting to HTML now, you can see what I have now. Sample, this is the author name, the title that I already put earlier on. You can see this is just a sample code. So this is an R Markdown. It's usually used for creating reports. Or you want to create outputs, or you want to export to other, or export your code to other outputs. So always go to write in R Markdown. But now we already have Quarto, which usually use. I think the book also covers Quarto, which with time, I'm very sure we'll get to that side. So it also works better than the R Markdown. I can also use it to create PowerPoint slides too. Also, use it to create Word documents, use it to create PDFs. I also have Shiny for creating applications using R. You want to create a web application, you can use the Shiny. This is also a package on its own. And it also has some packages that are depending on it. So we have various packages under Shiny. Shiny is the main application. I also have the study group too for Shiny, where we are covering, I think we are covering, I'm trying to remember, I think building interactive applications with Shiny. I think that's the name of the book. There's also another study session. I think that one is coming up next week, because really. So there's another study group for the Shiny. So the Shiny allows people to create web application using R. So you can create dashboards, okay, with Shiny. We have code folding. So code folding is usually for collapsing your code. So for example, now you have a function here. So let me just create a function. Let me see. Function, okay, let me see some function, comma B. So this is a function that sums two numbers. So this function can actually be longer than this. So there is this arrow now, you can see it clearly. It's usually to fold code. You can see it's showing fold code. So once I do like this, it's going to fold the code. So this is very useful when you are dealing with long lines of code. Let's say you're dealing with over 200 or 100. So to make you easier for you to work with your script, you can just fold the codes that you are not currently working on. You can see I can just click on unfold code. So most of the times, even by clicking here, I can also unfold the code here by just double clicking on it, or I can just use this arrow to fold the code. So you can see this arrow usually use the code folding. It's also very important and increases efficiency when you are working. So I already talked about the working directory too also. Explain the working directory. This is your working directory. So most of the times the folder you're on. So if I go to this terminal now, you can see my working directory. You know, earlier on, we're still working on an R project. So we're on under 5 children. That's the title of our working directory. So you can see it here. It's under documents and under the user PC. You can also set your working directory. You can change your working directory directly using the set working directory command. So I can also set it manually. You can set it manually by using point and click to set your working directory. So most of the times, even closing your project safe, you can actually use it to change your working directory. So you just run the set the working directory command. You paste the part of the working directory you want to go to, and it's going to take you to that particular working directory. So I think I've talked about within an R project, okay, and working directory on R Markdown. So I think this is the code of knitting too also. This is just, if you want to knit it. So knitting is just like compilation. Just put something like compiling your file. So that's what we did with this particular Markdown We just knitted it. So that's the code for you to knit it. So these are the options. Most of the time, it's just easier to just use this option. I'm just going to click it and it's going to knit it for you. So you can use clear knit catch. You can see that there's the HTML file here. By knitting, it's going to be storing the HTML file for you. So if I say clear knit catch now, you can just clear the knit catch for me. So you can see that if I want to knit now, I can still knit either to HTML, to PDF, or to Word. So most of the times, if you want to knit to PDF, you need external dependencies, such as text for you to knit to PDF. But most of these are just about the file parts. We have broken parts. So you also have problem of file parts. If your file part is not correct, you can have issues. So most of the times, we use the /, but Windows usually use the \. In Windows, the \/ is used. That's why I have to be very careful when copying file parts. Windows uses the \, but for using broken parts, you use the /. So when you're copying a part, you try and make sure you change your parts slashes to / when you want to copy it inside R. Most of the times, R works with /. Also about objects, we have already talked about objects. We're explaining of what objects are, and also I can create them using this. And we have various types of objects. We have data frames, we have vectors. So we have data frames, we have vectors. So we have various kinds of objects which you can have in R. And we have various classes of objects. So now, this is, for example, now we have any data you import, that's a row and column. Maybe, for example, a CSV file or an Excel file. So that's usually an object and usually called a data frame. So R is going to take it as a data frame object. So that's what R is going to take it as, a data frame object. So for example, this one now is going to import my line list.csv. So here now is just the structure of an object. You can see a vector here. This is a matrix. A matrix is usually a two-dimensional, is two-dimensional. So we have rows and columns for a matrix. One array is three-dimensional. So what means an array can contain a matrix can contain a vector. So we have a data frame that's just a table format, and we have lists too also. So these are the various object structures that we have in R. And also have classes of objects. So the difference between the structures and classes. The structure of an object is just how the object is structured. In which format is it structured? Why class is an object is just like the object type itself. So we have characters, which are usually texts. We have integer, usually numbers, whole numbers. And we have numeric, which are usually decimal numbers. We also have factor. So this factor are usually used maybe when you are dealing with tables. So you have factors that are dealing with prediction of whether somebody is dead or not inside a particular data that you have. So you can actually categorize that particular table into a factor. This is another object class. Then we have dates, then we have logical, then we have data.frame, then we have table, then we also have lists. So most of the times you work with character, integer, numeric. Most of the times you work, and then you work with lists. Most of the times and data frame. So with times also you can also work with logical. Data.frame and table are almost similar, only that table is more faster and it's more of the recent object class for data sets than you have. We also have logical, which are Boolean values, true or false, and we also have date. So date itself also has a data, also has an object class and so on. So you can also check. So for example, now you can also check the class of an object like the A, let's say A is equals to 5. I can check the class using the class function. It's going to return the class function, telling me it's numeric. So I can also have B is equals to boy. I can check the class using the class function of B. You can see I'm having what character. So the class function allows you to be able to know the various object classes that the classes of an object that I've already created. So this is a vector. I already explained earlier on. Anything that you created using this particular C command or C function is called a vector. So vector is just a group of elements that are together. But most of the times, when you want to create a vector, the elements have to be of the same data type or object class. So if I say A is equals to C 4,5, you can see that A If you check my environment, A is already created. You can see it's telling me that it's numeric. And it has what? It has 1 to 2 elements. Indexing in R starts from 1 to 2. 1 and 2, 4 and 5. So if I say class of A, you can see it's going to return numeric for me. So you can see it. So you can see what if I say A is equals to C, boy, and 5. You can see now this time around is carrying what? It's carrying 2 objects of different object class. So we have boy and we have 5. So you can see that what the first one is going to, what it does is that it actually converts this value, because a vector has to be of the same object class. So it's going to take this 5 and convert it to a character. That is why you see 5 is having quotations. So, and similarly can happen if, for example, now I say A is equals to C, true, and that's. So true is actually a Boolean data class. You can say class of true now, true on its own, because you cannot create a variable called true or object called true. It's actually a logical object class. So, but because I'm using it in a vector with a character, so it's going to coerce it into a string. So that's why I see true is carrying quotation marks. So a vector must actually contain an element of the same object class. So you cannot have different object class inside a vector. So, and you can also convert it yourself to also using the functions as.character. So if I have, for example, true, I can convert it to as.character, or as.numeric, I can convert it to a numeric class, or as.integer. So those are the various ways which I can convert any object class I have using the following commands. They're actually straightforward. So I actually have what's called column variables. So column variables. So this, for example, this particular code now, so this is a column. This is actually a vector of character values. You can see it here. And this is explanatory variables. So I can actually, for example, now if this is, okay. I think, let me see. It should be, and so you can actually index this particular vector now using their indexing. Each of them starts with position 1. You can see the positions given here, 1 to 6. You can see 1, this starts with index 1, 2, 3, 4, 5, 6. These are the various positions. So you can get the value of each position using the index value. That's when you can see X. You can see the particular index is 5. So this is how you can just index a particular vector. You can also apply the same indexing to also with data sets. You can use the square brackets. You can use the summary to get summary of a data set. When we start working with data sets, I think we'll see how some of those functional works. So also have what's called lists. So you can actually create a list. So a list is also a group of all elements, also similar to something like a list is more or less similar to a vector. So except that for this fact that a list can contain, let's say we have a list here. List 2, 3. So this is a list. So you can see it here. It lists all the items in this place. And a list, unlike a vector, it can carry object classes of different class. So it doesn't necessarily, they don't necessarily need to be the same object class. So that's what a list actually does. So we also have a data set. I think there is a former popular data set, Iris data sets. So this is actually a data set you are seeing. So this is how it looks like. You can view it using the command view Iris. So you can see it here. This is the data set. You can see view Iris. So if I want to check, get only contents of my first column, I can use the index. because if this is the first column, so the index is going to be 1. You can see it here. And for the second column 2, or let's say the third column, I can use 3. And this is it. So this is the indexing of the third column. So you can also do that also for other columns. So we have what we call piping too also. Piping is also used to pass operation to another operation, which usually comes with the dplyr module. So let's say, for example, now you have various functions. Instead of just, if you have a function, for example, now that this, okay, I want to print, okay, let me say A is equals to 7. And I want to say print the square root of 7. So you can see that I'm putting a function inside a function. So, but with piping, I can actually say print, then square root of 7. Okay. Okay, let me see. Okay, I think it should be square root of 7. Print. Okay, so this is the correct, so it starts from the inner function. So this is how piping works. So instead of writing a nested function like this, so you're going to be taking the functions inside first. So let's say you have a nested function like this, print square root. We have sum of let's just say 5,6. So instead of writing a nested function like this, you just use a pipe operator. You can just say sum of 5,6, then square root, then print. So this is how a pipe operator works. So this is, you can see we have the same value. So this is how a pipe operator works. So this is for the native pipe operator. I showed you how to set it earlier on. And this is how the pipe operator, this is how the pipe operator, where is it? Okay, this is how the pipe operator for dplyr looks like. So you can use any of them. It's based also on your preference. So these are just the key operators and functions in R. We have relational operator, less than or equals to, logical operator, handling missing value, and mathematical operator and functions. And we also have the in operator to check if something is inside a list or not. So these are some of the assignment operators that we have. Or this usually is the writing functions. It's also used, this from the Magritte package. So this is the package that actually contains the pipe operator, but usually installed with most of the packages that are under the tidyverse. So we have relational and logical operators too. Also, we have the equals to, not equals to, greater than, less than, greater than, equals to, less than, equals to, or you want to check if a value is a missing value or not, or if value is not missing or not. So we also have the logical operator and, or. We also have parentheses used to group criteria together and clarify order of operations. So you can see, for example, now, this example is saying mutate. So this is a function that usually is used to change a column name. So change a column name if these following conditions are met. So these are the conditions that have been given. If there is a missing value in this particular column, and if also there's a missing value in this other column, and if this column is equals to positive, that particular row is positive, and also that particular row for that column is positive. And also other cases in home, if this also column 2 also is what? Yes. So this is just a condition which will also go to some of these packages later on. So this was a script that shows us how conditions can actually be used to filter a data set. So also have missing values too. Also, you can check your missing values in the function is.na. And these are the various mathematical operators, how you can use them. Exponent is actually used using this sign. Now we have the other signs, which are just the regular signs of operation. You can use the bracket to specify the order of an operation. And these are various mathematical functions. We have already used square roots. So this is the square root function. We've already used it. And these are other functions too also that you can actually use. A scientific notation can actually be turned off using this particular code. We use it, option SciPen 999. If you want it, you can actually, if you don't want it, you can actually turn it off using this. So using SciPen is equals to 9999. So we have statistical functions too, also the mean, the median, the standard deviation. These are there are a lot of functions that are like the sum. We also use the sum recently. So these are a lot of functions that one can also use. So we have for creating sequence, we have for replication, or repetition, we have cut, we also have sample for taking a random sample. So this one also checks if a particular value is in a vector. This is in. So this is the in. You can use it to check if a particular value is inside a particular vector. So I also have error and warnings. At times you can get errors. Errors means that this particular code you are trying to run cannot go. While warning means that though your code is running, but it's going to have like an effect or a side effect which you need to check, or something that might affect you later on. So means a warning can, when you get a warning, it means that your command can actually be completed, but there's something unusual with what you have. Or when you get an error, it means that your command cannot be completed. You need to go and fix the problem that you have. So I have general syntax tips when writing other commands to avoid error. And one is you can just cross-check your work, avoid spaces in columns and object names. You can keep track of and remember to separate your function arguments, count the number of opening for each code chunk, and R also is case sensitive, which means these two variables are different from each other. So one has to take note of that. So I think this is for chapter 1, and I'm very sure most of us have already gone through it too also before we came for the session. So I don't know if there's any question. Okay, are we there?
Yes, we're following.
Okay, is there any question? Or any clarification, any contribution? Okay, I will take that. Okay, no question or contribution.
Well, thank you so much. Mine is just an appreciation of the presentation. Thank you so much. I think
You're
it's a
welcome,
very
sir.
nice refresher for me.
You're welcome, sir.
Yeah, I look forward to more of this.
No, you're welcome. Okay, so thank you very much. So based on that, I don't know who is going to take chapter 4 in our next session. So I think we have, we're having a session in a month. I don't know if it's 2 sessions in a month or a session in a month. So who is volunteering to take us chapter 4 in the next session? Okay, I'm listening. Okay, Mr. Lukman, are you there? Mr. Lukman, is he there? I think I will go back to the meeting. Okay. Okay. Okay, I think since there's no question now, though our next session now, I expect, I don't know who's going to volunteer to take the next chapter for the next session. Just chapter
Sorry,
4.
when is the next session coming up, really?
Okay, though I don't know. Let me I don't know. The host, I think the hosts.
Okay. Okay, let me come in.
Okay.
Okay, thank you. Thank you so much, Ridwan. Thank you very much. And thank you everybody for joining us today. So we're going to be having a session every month because we have 4 classes, 4 study groups. So we have one for R for data science, geocomputation in R. We have R for epidemiology, and we have R Shiny slash Python. Okay, so we can actually use R or Python for creating Shiny apps. So because of that, we don't want to get ourselves choked because there are so many people who are having multiple study groups that they're combining. So today is kind of the first session. That's why kind of we are slow. And we also believe that, okay, we should kind of familiarize ourselves with the way the study group is going to be like. So what we expect is this: if you're going to join the other study groups, you can join, but it's going to be in the last 2 weeks of the month. The last 2 weeks of the month. That's the 3rd week and the 4th week. So for each one, we have on Wednesdays and Saturdays. So it's Wednesdays and Saturdays. So we have R for data science on, well, last Wednesday, then today R for AP. The on coming Wednesday, geocomputation. Then the last week and Saturday is going to be for Shiny apps. So we don't want to take too much so that we don't choke ourselves. But for the subsequent sessions, we might not be taking just one chapter. We might be taking like 2. So it depends on how fast we can go. So that's just what and we're looking at every one of us to read the book before coming to class so that it's going to be much more faster. So it's not going to be baby steps anymore. So that's the way we can all benefit from it, and we can all contribute as well. So we can see we have so many chapters there. So we're hoping that we'll be able to benefit from it. But by the time we take the first few chapters, we should be familiar with R and we should be able to move faster. So that's my contribution, the response to that. So Ridwan, I'll hand over to you.
Okay.
Thank you so much.
Okay. Thank you very much, Ma. And thank you very much, everyone. So I think we expect us to read the next 2 chapters that we're going to be taking. So let's try and benefit from the book and the time that we have. So yes, I think I expect all of us to check the next chapter. So I don't know, is Mr. Lukman still available? Okay. Okay, no problem. So I think that's it on my own end. So please, let's endeavor to check the chapters. And also, I don't know if some of the chapters have exercises at the end, so you can also go through them before we even come to the class. And also another important thing is that most of the times when going through it, so some of us might find some concepts difficult to understand. That's when we start going deep into some chapters. So this session allows you to discuss on those concepts and clarify everything on ground. So that's it from our end. Thank you very much, everyone, for attending the session. It's a pleasure meeting all of you. Have a nice day.
Okay, bye, everybody.
Thank you.